right. So we're going to work through some examples today dealing with interpreted spectra and also talking about like some complex splitting. Uh, I think that won't be too bad once we get to that particular example. And then we're going to talk about how to assign spectra, and then all of our interpretation is going to be on what we already know. So splitting patterns, chemical shifts, and integration, and things like that. So we got 4 molecules that we're going to look at. Excuse my chicken scratch. I'm writing with the mouse now, right? 4 and 6, and you don't see that, and so that's an immediate clue that we can rule that molecule out. We can rule this one out because that has 7 signals, and then we can rule this one out because it has 6 signals. But we've already solved it, right? Are you following? Okay, so this molecule here is what we're going to be working from. We know it's not this one, right? So we have 1, 2, 3, 4, 5 signals. Let's see if we can figure that out. Which signals do you think are going to be the furthest downfield?
The one by the oxygen.
The ones here?
Yeah.
This one and this one?
Oh no, I meant never mind. Oh no.
Yeah, no, you're right. You're right. It's going to be these two are going to be furthest downfield. This, were you thinking about this one?
No.
You talking about? Oh, I was just circle all of them. Man.
No, I was talking about the ones you circled the first time.
Oh, okay. All right. Cool. All right. So these are going to be furthest downfield because they are adjacent to oxygen. Everybody okay with that?
Mm-hmm.
Right. Which one do you think is going to be furthest upfield?
Let's see, H3.
It's going to be one of these trees, isn't it? It's going to be this one or this one. Now we're going to be able to tell which one is furthest upfield by the splitting patterns. So let's start here. Let me erase this. Actually, I'm going to switch back to my iPad. All right. So here we can rule what we ruled out already. We ruled this out, we ruled this out, and we ruled that out. Is that right? So working with this one. And we said that the 2 protons here should be the furthest downfield. And then the 2 methyl groups are going to be upfield. What's the term again for when something gets shifted downfield? What's the term for when that happens? Anybody remember?
De-shielding.
It's called de-shielding. That's exactly right. Thank you. All right. So now let's see if we can decode this spectrum. All right. Where do you want to start? Do you want to start with the ones that are downfield, or you want to start with the methyl groups? It's your choice.
Downfield.
Okay, let's do those first then. That's fine. All right, let me erase all this. All right, let's start here. Look at the integration. We know the location. We know why it's downfield because it's next to oxygen. We've already established that. So now look at the integration and the splitting pattern. How many lines is that split into? Can y'all see that?
5, right?
5. 1, 2, 3, 4, 5. It's a quintet. Is that right? What does that mean?
It has 4 neighbors.
If n plus 1 is 5, that means n is 4. That's exactly right. So let's go back down here and see if we could pick which one it is. So how many neighbors? I need to change my highlighter. How many neighbors does this one have? keep in mind, don't think about, we're thinking about the hydrogen, but we're looking at the carbon that it's attached to when we're determining the neighbors, okay? So that carbon, the hydrogen right here, is neighbored by,
4 hydrogen. pH3.
you see that? It's got a neighbor here, and it's got a neighbor here. Is that right?
Yes.
And then on this neighbor, there's 1 hydrogen. And then over here, that's 3 hydrogens for a total of 4 hydrogens. Is that right? 4 neighbors. Yes or no? And if you don't see it, say something. So for this one, n equals 4, and then n plus 1 would be 5. So we can assign that signal right here. Y'all want to label it or give it a name? I'm gonna call it A, and we'll work our way back. A, and then so this is A, and then this would be B, but we got to figure out what B is. Is that right? So now let's look at this hydrogen right here, and keep in mind it's on a carbon, and that carbon has a neighbor on this side, and it has a neighbor right here. So for that set of protons, let's see what the signal looks like. It's actually, do you see right here? It's a quartet, isn't it? So N must be 3. Is that right? So if we go back down here, can we see how N is 3? Right? You got 2 neighbors on this side, or 2 hydrogens on that side. Is that right? And 1 on this side. Is that right?
Yeah.
So for this one, N is 3, N plus 1 is 4. So we're going to label that as B.
Why wasn't the carbon with the turquoise hydrogen 3s not counted with it?
It's too far away. When we talk about neighboring hydrogens, it's got to be immediate, like it's got to be bonded to that carbon. You follow what I'm saying?
Mm-hmm.
So this you see how if this is the carbon that we're looking at, you see how this carbon is bonded to it and that one's bonded to it. That's where your neighbor. When we talk about neighboring protons, that's what we mean. So what's how many hydrogens are on the carbon that's bonded to it on the left? How many on the right? So this carbon right here is too far away. Right? It's got to be bonded to it. Does that make sense?
Yeah.
All right. So that's A and B. Now let's work our way down the spectrum. We're looking at this signal right here. You see it integrates for 2 hydrogens. You also see that it's also I said quintet. I meant pentet. Let me change that. It's a pentet. All right. And you see here, this is also a pentet. Is that right?
Yes.
So what do you think? What are my choices? Right?
It was 4 neighbors.
That means that it has exactly. That means it has 4 neighbors. N equals 4. So if we look at the CH3 here, how many neighbors does that have? How many hydrogens on the carbon bonded to it on the other side?
2.
2. What about this CH3? How many neighbors does it have?
1.
1. Right? So for this one, N equals 2. For this one, N equals 1. Right? So what's left has to be this set of protons right here. Is that okay?
Mm-hmm.
Now, what's bonded to the left of it? This carbon, right? No, I'm sorry, this carbon. Is that right?
Mm-hmm.
Yes.
How many hydrogens on that carbon?
3.
3. What about on the right of it? How many hydrogens are on this carbon?
1.
1.
One.
Good. So N for this set is equal to 4, and then N plus 1 is 5. So it should be a pentat. Is that right?
Yes.
Yes.
So we're going to label that. We're going to label this one as C. Any questions about that?
No.
All right. Now we got a doublet and a triplet left, both integrating for 3 protons. So you know it's going to be one of the 2 CH3s. Which one of those would you expect to be a triplet?
The one
The
where
pink one,
oh,
the pink
The one on the
carbon.
left?
Oh, let me,
Pink
I can
C.
leave that. If it's a triplet, that means N is what?
2.
2, right? So which one of those 2 methyl groups has 2 neighbors?
The pink one.
The pink one. Good. So we're gonna, but that's not in order because I don't want to do D and then E. Like I want out of order. So which one has 1 neighbor?
The 2.
The teal one, right? This one, right? So what we're gonna do is label that as D because that should be a doublet. Is that right? If N is 1, then N plus 1 is 2. So that signal should be a doublet. Anybody disagree with that?
Yes.
You do disagree?
No, I agree.
Okay. All right. I'm making sure now. All right. And then if we look at the next one, this has to be E. Is that right? So this will be D. And then this one will be E. It should be a triplet because it has 2 neighbors. Is that right?
Yes.
All right. So we solved that spectrum. We know what each one of those protons shows up. We know why they show up there. We know why they split the way they split. And we know the integration. Those are the 4 questions that you have to answer for any proton in an NMR spectrum. Why it's there, where it is, how many protons does the signal represent, and how is it split? If you answer those questions, you can solve any spectrum. If you can answer those questions. All right, we got to stop here because it's 9:54. Does anybody have any questions? I'm gonna stop sharing and stop recording.